Please turn on your cameras so I can, in order to prove triangles are similar, there are three theorems. One is angle-angle similarity that we worked on last class. And these notes are now typed in, hard-coded into homework 68. They're the same thing you should have gotten in 67. Continuing from here is today's work for notes in classwork 68. This will also be your homework. In order to prove that two triangles are similar using side, 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 what you need to demonstrate is that all of the pairs of corresponding sides are in the same ratio. In other words, I'm going to pick one of these sides, say the 9, and I have to find which of these sides is corresponding with it. And that can be hard because I haven't been given a similarity statement to tell me that. And obviously in this case, it's spun around a little bit. We don't know if it's just rotated or if it's rotated and reflected, or right? We don't know exactly what matches with the 9. But there are some tricks we can use. Notice that in this triangle, it's got 3 different legs. And the 9 that I've circled is the smallest, mediumest, or largest side.
Smallest.
Thank you, smallest. That's not supposed to be the hard part. So therefore, we would expect that in this one, it should also match the smallest. So I'm going to match that with 14, which is the smallest here. Alternatively, if I were to pick 13.5, that's the mediumest side. Therefore, I'd pick the mediumest side here to match up. And then 20.25 is the largest side, and so that should match up with the largest side. As a result of that, what I should be able to do is create a proportion. Now I'm going to go off on a little tangent here for a second and talk about proportions and how we can set them up. You don't need to copy this down. This is just for your level of understanding. If I had a 6-pack of sodas of some sort, or sparkling waters, or energy drinks, whatever it is you like, and let's say that, for example, it was $3 for a 6-pack. Alternatively, I could buy a single can for 50 cents. Now, this per unit pricing ends up being the same. I can tell you that. You can probably figure that out. But I use this as a model for how to create proportions. In this case, we're talking about 6 cans equaling $3. And here we're talking about 1 can being 50 cents. One proportion that I could make is I could say that 6 cans is to 1 can as $3 is to 50 cents. And that would be a valid proportion. But I could also say that 6 cans is to $3 as 1 can is to 50 cents. And that would be fine. I could say that 50 cents is to $3 as 1 can is to 6. There's a bunch of ways I can do this. But what I could not do is say 6 cans is to 50 cents as 1 can is to $3. So the point of this discussion right now is, how can you tell which proportions work and which don't? And I have a way of thinking about it. When we talk about, when we talk about the number 6, 6 is the number of cans in the 6-pack. 1 is the number of cans in the solo. $3 is the price of the 6-pack, whereas 50 cents is the price of the solo. It's a valid proportion if, when I look at this stuff vertically, they have something in common. Well, these are both numbers of cans. And when I do this one, these are both dollars, so they've got something in common. And I also need that to work horizontally. So when I look at these two, they have to have something in common, and they do. They're both related to the six-pack, whereas these two are both related to the solo. If my verticals have something in common and my horizontals have something in common, then this is a valid proportion. So these are both six-pack related. These are both solo related. The top ones are quantity of cans. The bottom ones are dollars. These are both money. These are both quantity. These are both solo. These are both six-pack. But here, when I'm trying to match the 6 with the 50 cents, there's nothing in common. This is number with a six-pack, and this is dollar with a solo. There's nothing in common here. As a result, that proportion will not fly. Because these all work, what you'll see is that after your first step of cross multiplying, you'll get 6 times 50 cents. You'll get 6 times 50 cents. You'll get 50 cents times 6. This one, you would not get 6 multiplying by 50 cents. That's why this one won't work. So when I look at these, I have a choice about how I'm going to set up my proportion, but I have to match them. So I'm going to take the smallest sides, 9 and 14, and I'm going to make that 1 ratio. And I'll set that ratio equal to the medium. And I want to see if these two pairs of sides have the same ratio. In other words, if they're proportional. So the way I do that is I cross multiply. I say 9 times 21 equals 14 times 13.5. Take out a calculator. Say 9 times 21 is 189. And 14 times 13.5 is equal to 189. Ah, great. So that verifies for me that these two pairs of sides are in the same proportion. The ratios are equal, which tells me that I have 2 of the 3 sides matched. I know that these 2 pairs of sides are in the same proportion. If I want to use side-side similarity, I now need to come up with a third matching side. So obviously I've got to use the red one here. So I'm going to go with 20.25 over 31.5 equals, but what do I set that equal to? I need to see if it's in a proportion with something else, and I've already used these up. What do I put over here?
X or 189?
Well, it's a good idea, but this is a fraction, right? 189 is kind of a fictitious number. That doesn't really come out of anywhere. It doesn't mean anything. It's not like the scale factor going from here to there. What I want to do is I want to see if this S is the same as these S's. So I get to pick either one. I can either choose 9/14, again, right, reusing that one, or I could choose 13.5 over 21. Whichever one I want, I'm going to have to reuse this because I want to see if this ratio that I've already said is the same as the green one is also the same as the red one. And to check it, I'm going to do my multiplication. 9 times 31.5 and 14 times 20.25. When I multiply those out, 9 times 31.5 is equal to 283.5. Again, there's nothing really significant about this number, like there was nothing significant about the 189, except that I want it to work on both sides. 283.5. Great. This works in both ways. So this tells me that this particular piece over here validates that the red side is in the same proportion as the green, as the purple side. And we've already said that's the same as the green. Therefore, that gives me my third S saying that all 3 sides are in the same proportion. The ratios are all equal. As a result, that gives me the ability to write that yes, similar by SSS, Similarity. And notice that this is really close to the theorem we used for proving triangles congruent, where we said SSS. The only difference is this little symbol at the end. And that may seem trivial, but this is a symbol effectively. And it's a symbol that is different. This part is different than the one we used for congruence when it didn't have that. Without it, the message I'm conveying is if three pairs of sides in a triangle are congruent, if three sides in one triangle are congruent to three sides in another triangle, then the triangles are congruent. This little squiggly changes the theorem entirely. It says if you have two triangles and the ratio of each pair of corresponding sides is consistent, then the triangles are similar. Totally different theorem, even though it looks very close. So make sure you write similarity after the SSS when you're justifying this. Having justified it, I now need to create the similarity statement. So I'll use this one first. I could choose these three letters in any order. First one's free. I'm going to go with K and R. K and R. But now that I've done K and R, I have to be very careful. K is the angle in the corner of purple and red. So here's my purple, here's my red. D is the one that matches to that. Then I traveled from K to N. So I traveled along the purple side. So from D, I'm going to travel along the 14 to get to E, leaving S as the final side. That's my completed demonstration that they are similar by side, side, side similarity. And boy, last class we did these angles where you're like, yep, done, and just jump to it. There's a ton more work associated with side, side, side similarity. Please just accept that and know that's the case. And yes, you have to show this work. Any questions from our first example? Okay, so now this one. What are the three sides I need to compare? Well, let's say that 20 is one of them. What should I match 20 up with? I mean, really, I'm going to be doing it for all three sides of this triangle. So maybe I'll do 20 there, 15 there, and 30 there. What should I match up with the 20?
28.
Good, Josh. So you see that the other triangle we're talking about is this overlapping triangle. And if this is 20, then you go 8 more. That means this part is 28. And with the 15, I go 6 more to make 21. And with the 30, that one's 42. Now, I'm hoping these are all the same, but the way I validate that is by picking 2 of them and demonstrating that they're in the same proportion using cross products. So 20 over 28 equals 15 over 21. Cross multiply. 20 times 21 equals 15 times 28, and see that that number is the same on both sides. So 420 equals 420. So that's good. That gives me how many S's?
2.
2. Good. That gives me 2 S's right off the bat, which is easy. But now I need to get another one. So this is my orange one. What should I do 30 over 42 to? What should I try to match that to?
15 over 21.
Sure. It's as good a choice as any. So 15 over 21 equals 30 over 42. I can even see this one. Can you guys see it? Because 15 gets doubled to get to 30 and 21 gets doubled to get, yeah. So actually it's going to go really, it's going to happen for sure, but we got to show the work. So this is going to be 630 equals 630. Yes, that works also. Therefore, we end up with, yes, similar by side, side, side similarity. And that lets me state the triangle similarity. WVX, first one's free. And now I need to match it. So we just went along the same one. So this is visually supported. So WUY. What do you think? Any questions on that? How does SSS similarity feel so far? 5. I think I can do these. These seem really easy. 3. A little practice and I should be able to pull this off. It's kind of a lot of work, but I can do it. 1. I'm not really clear on this yet. It doesn't make a lot of sense yet. Good. All right, so let's go to page 2. And we'll see some at the top here. Why don't you guys please try doing 9 and 10 yourselves while I'm sitting here, and then I'll go over them in just a minute. Go. So those two are the smallest side, so that's going to be one of my relationships. Then I'll look at the mediumest side. I'm just going to do those first. That's going to mean that 5 times 12 should equal 7 times 4. So 60 equals 28. Huh, did I set those up right? 5 is the smallest side, 12 is the mediumest, 4 is the smallest side, 7 is the mediumest. Yeah, they're not in the same proportion. Therefore, I can't say anything about this. I'm going to say not similar by side, side, side similarity. In fact, in this case, I can make the conclusion that they are specifically not similar. It's a strong statement to be able to make, but if they were, those sides would have to be matched up. Okay, let's take a look at number 10. All right, so again, it's all sides. So I'm going to take my smallest one here and my smallest one here and say 5 is to 18. And then 12 is my mediumest. 43.2 is my mediumest. And I want to see if those are in the same proportion. So therefore, 5 times 18, 43.2 times 12, and I'll use my calculator here. 5 times 43.2 is equal to 216. 18 times 12 is equal to 216 as well. Okay, so that one works. That gives me 2 S's. Now I need to set up my third one, 15 and 54. And 15, the smaller ones on top, right? Yep, okay. 15 and 54 equals, and I'm going to do the 12 and 43.2. Could have done it either way, but that's what I chose. So 15 times equals 54 times 43.2, 12. So I get 648 equals 54 times 12 equals 648. So that gives me all 3. So I'm going to say yes by side, side, side similarity, which means I can demonstrate that they're similar by using a similarity statement. So I'm going to go with wrap. And R is between purple and blue. So purple and blue, it's again R. I went along the purple to A, so I'm going to go along the purple to T and then Y. Okay. Any questions? Oh, wait a minute. I made a mistake. Somebody caught it. Here, I went left to right, 5 over 4, and then I went right to left. So this was a flawed way to set this one up, wasn't it? Thank you for catching that. Let me do that again. I'm not sure if it's going to work or not. So I'm going to go left to right. I'm going to go 5 over 4 equals, and left to right is 12 over 7. And so then when I cross multiply, I'm going to get 5 times 7 equals 4 times 12. 35 equals 48. So the result is the same, but this is not a valid way to do it. This is the way to do it. Thank you very much. Appreciate you correcting me. Okay, any questions on these? Okay, how do you feel now? Give me a 5, 4, 3, 2, 1. 5, I can do these, fully confident. 3, another couple of samples would help me feel good about it, but I think I can do it. 1, I've got some struggles, I'm working on it. Okay. All right, so I'm going to leave 11 and 12 as homework problems for you. Please note for number 11, don't forget that the Pythagorean theorem can help for finding the missing side. Okay, we're going to move down here to the next one, side angle side similarity. This is the third and the last theorem that proves triangles are similar. And it's kind of a hybrid of the other two. It's not quite as easy as angle-angle similarity, but there is an angle. So for instance, here we see that this angle is vertical. I can mark that that's congruent. I don't have to do any hard work on that. And then I have to find one pair of sides. So because I'm doing one pair of sides, it's only going to be one proportion I have to solve. I won't have to do twice. But when I set this up, note that it could be 6 to 48 and 12 to 24, or 6 to 24 and 12 to 48. How do I pick which one goes with which? Well, if 6 is the smaller of these two, it must match with the smaller of those two. And if 12 is the larger of those two, if it's going to work, it's got to match with the larger of these two. So then 6 is to 24 as 12 is to 48. And again, you know, when I made that mistake earlier, I really should have caught that, because 5 over 4 is a fraction greater than 1, whereas 7 over 12 is a fraction less than 1. That would never have worked. At least when I did it correctly, 5 over 4 and 12 over 7 are both fractions greater than 1. So these are both less than 1 because the denominator is bigger, and that allows me to do cross multiplying. 6 times equals 24 times 48 times 12. And again, we can see this one's going to work because 6 is doubled, 24 is doubled. So 6 times 48 is 288. 24 times 12 is also 288. And that validates, giving me 2 S's. And they're the right 2 S's. They are straddling the angle, SAS, with A in between. So yes, by side angle side similarity, don't forget that little symbol there, I can say that triangle, let's go with the bottom one here, SER is similar to, okay, S is between purple and the blank. So here's purple, here's the blank. So G, and then I went down the purple, so down the purple, GEF. I'm gonna just circle that so it's easier to see. Okay. What about 14? Well, this is not a right triangle, so I can't use Pythagorean theorem here. If I don't know this side, I can't find it from these two. And I can get that these angles are congruent, but I don't know anything about this side and this side. So not by SAS similarity do I know if these triangles are similar. I don't. I can't make that conclusion because 40 to 25 could be 44 to this and this to this, or it could be 40 to 25 is this to this and this to this, and I don't have enough information. So it's really unknown. Okay. About SAS similarity. 5. I think I can handle this. Looks very straightforward. It's like the others, but easier. 3. Again, little practice will tell me if I understand it, but I feel confident at this point. 1. I do not feel confident. Proportions or fractions or ratios or cross multiplying is hard for me. Okay. I'm going to be leaving these 4 problems along with this page. It's not a 2-page document, it's a 1-page document for you to do as your homework tonight. I want to just go to this next part, which is proving triangles similar. I'm going to walk through this one with you. Okay. So we're doing proofs here. You might remember a 2-column proof like this begins with some free information. What's the free information I can enter in there now? What do I get to put in here that's just free? I know it's easy, it's done. Good, thank you, Juliet, the given. So I can take this piece and say MN is parallel to JL, and that's my given. One more thing, what can I do that I know is true or know belongs in here? May as well just transcribe it in there now. The proof, exactly what it is I'm aiming for. What's my destination? So I'll take this and say triangle JKL is similar to triangle MKN. Now, what about over here? Do I have any sense of what could be here for the reasons? What things would prove that 2 triangles are similar? Well, we've only got a few. It could be angle-angle similarity, it could be side-angle-side similarity, or it could be SSS similarity. I don't know which one yet, but it's going to be one of those 3 things. So, do I have any information in this picture that would let me do that? Any thoughts?
Angle K.
Angle K, okay. So we know that this angle is the same as itself. Angle K is congruent to itself because that's reflexive. And that, of course, rules out the idea of side, 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 because we've already got an angle now. And it could be that this side is to this side as this side is to this side, giving us SAS. Or it could be that we've got another angle pair. And of course, the irony is, if in fact these are similar, which they are, then both of those statements would be true. It's just a matter of what evidence we have in front of us. We don't have any evidence about side lengths right now. Therefore, we're going to have to look at angles. What do you know about this angle and this angle? What kind of angles are they? What do we call them? If these 2 lines are parallel, and this is a transversal.
Consecutive.
Close. Starts with C.
Corresponding.
There you go. Good. Corresponding. So since these are corresponding angles, and I know these are parallel, I can say that angle KMN is congruent to angle KJL. Now, personally, if I were writing this proof from scratch, I would probably like an extra line or two in there to say this is a transversal, these are corresponding angles, so that I can say if parallel and corresponding, then congruent. But I think we're conveying the right information. So that means that I've got two angles, which allows me to prove that the triangles are similar by angle-angle similarity. And I'm done, QED. Easy peasy. When we're proving triangles are similar using angle-angle, it's very familiar to us because we have a lot of information about corresponding angles, alternate interior angles, reflexive angles, vertical angles. To use the other two, one would think would be much harder, but let's skip to number 3 and I'll show you it actually turns out to be trivially easy. So how should I start here?
Given.
Start with a given. So I'm going to say WY bisects angle XYZ, given. And I know that I'm going to end up with triangle WXY is similar to triangle VZY. I don't know what my reason is going to be here, but it's going to be one of those three. Before I put in the second given, what information is this going to give us? What does it mean that WY bisects XYZ?
That they share a common angle.
True, but it's more than that, right? The word bisect is very specific. That bi in the front is a trigger. What does that tell us?
The two angles on each side of the on either side of the line are equal.
Exactly. Good. It splits it in half. Bi means to cut it in half. So I know that angle XYW is congruent to angle ZYW, and that's the definition of angle bisector. In other words, that gives me an angle pair there. Now I'm going to take my second piece of information. XY over ZY equals WY over VY. The fact that they tell us that this angle, this side pair and this side pair are inner proportion gives me how many S's? Gives me 2, doesn't it? So that's it. It's almost trivially stupid to do a proof with sides because they pretty much got to give you the sides. And if they did an SSS, it would just be here's one pair, here's another pair, done, SSS. So these ones are actually easy. These ones are a little harder because these require you to use angle-angle similarity. But I think you've got,
Erlin,
yes.
can you go back down for just a sec?
Sure.
Perfect. Thank you so much.
Sure. I think you've got the foundations for what you need. We have, what is it, it was 12:45. This is third period. So we have 25 minutes left. Your homework is to finish this packet. There is no additional big ideas. So what I'm going to do is put you into breakout rooms and I'm going to have you go in there for at least 15 minutes. After 15 minutes, I'll pull you out and see if there's any questions. And then I'll let you take off and spend the last 10 minutes doing it solo.
Mr. Erlin,
Yes.
are we going to do anything with the notes from Tuesday?
So the notes from Tuesday were, you mean, are you going to submit them?
Yeah.
Did I not put that up in Canvas?
Oh, I don't know. I haven't looked yet. I was just wondering.
I would say yes, you're going to submit them in Canvas, but don't finish them, right? Because there were only a couple of pages worth, 3 pages, I guess. Don't finish the part that we did today. That's today's work.
All right, thank you.
Okay, I'm opening up the rooms now. Riley, you there?
Yes.
I have sent you into the breakout rooms to work on this packet, please. That's your homework. So finish that up and then you can post it in Canvas.
Okay.
Thanks. Colette, you there?
I don't see a breakout room thing.
Okay,
Sure.
I'll send you a new one. Did you get it? What's up, Abdullah?
Yeah, I have a question.
Yeah.
So, regarding my grade for this class,
Uh-huh.
if I get a good grade on the test, will that bring it up?
A good grade on which test?
The unit 7 or the 6.
The transformations one?
Yeah.
Yeah, I mean, of course. If I don't think what's in the grade book right now is up to date, but if you never turned that in, that would be a 0.
Okay.
If you turn it in with even haphazard work, that would be a 50%. So that's far better. And if you do a good job with it and just get it right, you get 100%. So yeah, that's a great way to improve your grade.
All right. Because I would not think it's possible for me to turn in all the notes and the homeworks. Maybe the big ideas though.
Yeah, there aren't very many big ideas at all.
Yeah, there's only 2 or 3, right?
Right. Have you done the homework, the notes and classwork and stuff, and just haven't turned them in, or you just haven't been doing it?
No, I've been doing some of them. Some of them I do.
Okay, well, make sure you turn those in, because that's a 3 to 5 minute effort, whereas big ideas will take 45 minutes.
Okay.
So get as many of those in as you can.
Okay.
I'm gonna pull everyone back now.
And so you said they would have to be turned in by tomorrow at 2 p.m.
No, I said before Saturday morning for sure.
Oh, okay.
I mean, well, honestly, Abdullah, if you need more time than that and it doesn't come in until Thursday of next week, I'll catch it eventually. I'll fix it eventually. It just might not be on the report card for this particular round.
Oh, okay then.
So get it turned in. I'm not going to close the door on it, but I just won't be able to get it in time.
Oh no, I totally understand that.
Okay.
All right.
I'm bringing everyone in now. Okay. Can you give me some feedback on how that went? Hold on, let me give you a prompt here. Just a minute. Don't do it. Don't do it. Don't do it. Don't do it. Okay, give me a feedback. 5, it's really easy. I'm cruising along and doing really well with it. 3, I think I'm doing all right, and there might be some challenges coming in. 1, I feel insecure about it. I'm not really sure what I'm supposed to be doing. Okay. All right. Well, for those that just gave me a 3, 4, or 5, I think you've got what you need. I would be happy for you to be released now, and you can spend the next 10 minutes either doing this work, or you can postpone that for a later time. Just finish up this packet and submit it as your homework for 68. Those of you that submitted a 2 or didn't feel comfortable submitting anything, you should hang out and let's ask questions for a few minutes and get you more comfortable. All right, have a great weekend.
Thank you, Mr. Erlin. Have a good one.
Thank you.
Thank you.
Mr. Erlin,
Yeah,
I'm gonna go work on those assignments now. Okay.
sounds great. Thanks very much.
Thank you. So you said you will not be returning to campus on Tuesday?
I don't expect so. I'll find out tomorrow. I've requested the district to give me what's called a reasonable accommodation, which would mean continue teaching from here due to a medical condition. And I'll find out tomorrow if they approve it. If not, I'll be there and terrified.
Oh no.
Yeah.
We would not want that to happen. I hope
No.
you get approved for it.
Yeah, I mean, honestly, if everybody had a vaccine, I'd feel good. But I drive around town and I see so many teenagers congregating without masks. And
I see that too all the time.
yeah, and I just, I know that teenagers are impervious to it. And when they get sick, it's really minor. And as a result, a lot of them don't feel the need. But some of us have health conditions where it's different. And if we get it, it's a dire situation. So
Yeah, I totally understand. My dad is pretty old, so I understand that.
Yeah, it's a worse condition, and if he has asthma or some of the other conditions, it's much worse. So yeah. Anyway, thanks. I appreciate you asking about it.
Sure.
All right, take care. I'll see you on Monday.